Have you ever just turned on your tap, filled up a glass, and really truly wondered, where does this clean, clear water actually come from? Well, let me tell you, it's a journey that's way more complex and honestly pretty fascinating than you might think. So today, let's dive in and follow a single drop of water from a murky river all the way through a treatment plant. First things first, let's get a little perspective. We call Earth the blue planet, right? But, and this is a big but, check this out. Over 96% of all that blue is saltwater in our oceans, totally undrinkable. Most of what's left is locked up as ice or buried deep underground, leaving this shockingly tiny amount of fresh water that's actually easy for us to get to and use.
And if we zoom in even more on that tiny sliver, the water that's actually flowing in all of the world's rivers, the source for so many of our cities, makes up just this, 0.0002%. That's it. When you think about it like that, you realize just how incredibly precious this resource really is.
So, because this water is so incredibly scarce, and it's literally the starting point for what ends up in our glass, we have to treat it with a ton of care.
The thing is, that river water, our starting point, it's not just pure H2O. No way. Our little water drop has picked up a whole bunch of hitchhikers on its journey downstream.
So what exactly are we trying to get rid of? It's not just about visible dirt. Oh no, the challenges are way more complex than that.
We can basically group all these unwanted impurities into three main buckets. You've got the physical stuff, things that make the water cloudy or give it a weird color. Then there's chemical impurities, like dissolved minerals or even nasty heavy metals. And finally, you have the really dangerous ones, the biological contaminants, like bacteria and viruses that can make us seriously sick.
And this table right here shows why the source of the water matters so much. If you look at groundwater, it's been naturally filtered by layers of rock and sand, right? So it's usually pretty low in gunk and germs. But surface water from a river, it's exposed to literally everything. Runoff, dead leaves, you name it. It's carrying a much heavier load of impurities and needs a way more intense cleanup.
So, our water drop finally arrives at the treatment plant and immediately gets thrown into its first set of challenges, the pre-treatment phase.
The very first step is screening. The best way to think about this is like a bouncer at a club. You've got a series of screens, starting with big gaps and getting finer and finer, and they physically block all the big stuff. We're talking leaves, branches, trash, even fish from getting any further. Only the water gets on the list.
Next up is aeration. Here, the water is basically given a big breath of fresh air by spraying or cascading it. This does two really important things. One, it helps release stinky dissolved gases like hydrogen sulfide. That's the one that smells like rotten eggs. And two, it adds oxygen, which helps rust or oxidize metals like iron, making them way easier to remove later on.
All right, now we're getting to the real heart of the operation. This is where a little bit of chemistry and a little bit of physics come together to do something that honestly looks like straight-up magic.
So screening got rid of the big, obvious junk. But what about the millions and millions of microscopic particles that make the water cloudy and colored? They're way too small to get caught by a screen. So how in the world do you get rid of them?
Well, the culprits are these little troublemakers called colloidal particles. They're super tiny, but that's not even the main problem. The real issue is that they all have a negative electrical charge. So just like trying to push two negative ends of a magnet together, they're constantly repelling each other, just floating around and refusing to settle down. So engineers came up with this brilliant two-step solution. First is coagulation. They add a chemical with a positive charge, something called alum is really common, and they mix it in fast, like a super fast violent mix for about a minute. This zaps the negative charge on all those colloids. Then comes step two, flocculation. Now the mixing slows way down. It's very gentle, just enough to get these now neutral particles to bump into each other and start sticking together. And those new, bigger, heavier, sticky clumps, they have a name. They're called flocks. We've basically tricked millions of tiny, lightweight particles into clumping up into these bigger, heavier flocks. And that is the whole goal here.
But here's a tricky part. The amount of dirt and junk in the river water changes every single day, right? A big rainstorm can make it super murky. So how do the plant operators know the exact right amount of chemical to add to get those perfect flocks?
They do it with something called a jar test. You can pretty much think of it as a daily bake-off for water treatment. They take a few jars of that day's raw river water, add slightly different doses of the coagulant to each one, and run a little miniature version of the whole process. They're looking for that sweet spot, the smallest dose that makes big, heavy flocks and leaves the clearest water behind. That becomes the recipe for the whole plant for that day.
Okay, so after all that fancy chemical work and all that careful mixing, it's time for the big payoff. It's time to let a simple, powerful, and totally free force take over: gravity.
The water, now full of those heavy flocks we just made, flows into a gigantic, very calm tank. It's often called a sedimentation basin or a clarifier. In here, the water moves super slowly. And with nothing stirring them up, those flocks do exactly what we designed them to do. They sink. Gravity just gently pulls them right down to the bottom.
The whole engineering principle behind this is simple but so effective. See, the water is moving very slowly across and up, while the heavy flocks are trying to fall down. As long as a flock can sink faster than the water is rising, it's going to fall out and get captured.
And all that stuff that collects at the bottom, all the original dirt and clay and gunk, now all bundled up in those flocks, that stuff is called sludge. Special equipment scrapes it from the bottom of the tank so it can be taken away for disposal.
So let's just take a second and recap the incredible transformation that our little water drop has already been through.
I mean, it arrived at the plant as this murky liquid full of leaves, dirt, and millions of tiny particles. It's been screened, it's been chemically treated so everything clumps together, and then all that gunk settled out. The water is now visually clear, which is a massive, massive improvement. But the journey isn't over yet, not by a long shot.
Because think about it. We've removed all the things that make the water look dirty. But what about the things that actually make it dangerous? What about all those bacteria and viruses that are still swimming around in there? Well, dealing with those invisible threats, that's a job for the next stage of the journey.